Before we dive in, let's set the stage. In the last video, we crossed a line we never thought science would even approach. We talked about how galaxies actually existed before the Big Bang, and how the Webb telescope spotted 15 strange galaxies sitting far beyond where our theories say anything should exist. That episode wasn't just controversial, it cracked open the door to questions no one was ready to answer. And tonight, we're stepping through that door. Once again, the Webb telescope has left astronomers wide-eyed and scrambling for explanations. This time, it's not just another distant smudge of light, but a galaxy so ancient and so unexpected that it's forcing scientists to question ideas they once thought were settled. One discovery, and suddenly the early universe doesn't look as simple as we imagined. To see why this matters, you don't need to rewind all the way to the Big Bang. You only have to go back to 2022. Up until then, the record for the most distant known galaxy belonged to GN-Z11, captured by the iconic Hubble Space Telescope. At the time, it felt like a triumph. Hubble, with its 2.4-meter mirror and decades of engineering brilliance, had pushed human vision deeper into space than ever before. It had carried us across staggering cosmic distances, but even legends have limits. Then Webb arrived. With its enormous 6.5-meter mirror and instruments tuned to detect the faint, stretched infrared light from the universe's earliest moments, Webb didn't just improve on Hubble's work, it tore up the old rulebook and set a whole new standard. One of its early jaw-droppers was a galaxy known as Jade's GSZ 14-0. At the time, it became the most distant confirmed galaxy ever seen, with a redshift of 14.32. Redshift is basically cosmic stretching. The higher the number, the further back in time that light has traveled. But the universe wasn't done surprising us. Soon after, another galaxy stepped into view, MOM-Z14. Its redshift climbed even higher, to 14.44, pushing our gaze deeper into the universe's infancy than ever before. And it wasn't just how far away it was that made scientists pause. It was what this galaxy looked like. MOM-Z14 is tiny, shockingly tiny, just about 500 light-years across. To put that into perspective, our Milky Way stretches more than 100,000 light-years wide. And yet, despite its size, this little galaxy shines fiercely. Galaxies from this era are supposed to be faint, fragile, and painfully hard to detect. MOM-Z14 is anything but. It's bursting with newborn stars, flinging them into existence like sparks in the darkness of cosmic dawn. And then came the twist no one saw coming. There's no clear sign of a supermassive black hole. Normally, galaxies with this level of star-forming chaos are anchored by enormous black holes at their centers, cosmic heavyweights that regulate growth, shape structure, and influence how stars are born. MOM-Z14 seems to ignore that rule entirely. And the surprises didn't stop there. When astronomers broke down its light using Webb's spectrograph, they found something else that made them sit back in disbelief: nitrogen. A lot of it. That chemical fingerprint looks eerily similar to what we see in some of the Milky Way's oldest star clusters. It suggests stars in MOM-Z14 are forming in extremely dense, crowded environments. According to existing models, that kind of complexity simply shouldn't exist this early. Galaxies from this time were expected to be chemically simple, mostly hydrogen, a little helium, and almost nothing else. But MOM-Z14 is telling a very different story. Its chemistry implies that multiple generations of stars had already lived and died before we ever saw it. That alone hints that galaxies may have started growing up much earlier than we thought possible. And that raises an irresistible question. How many more galaxies like this are out there? Before Webb, astronomers believed galaxies from this era would be incredibly rare. Now, they're turning up again and again. These ancient, brilliant little red dots keep appearing in Webb's deep surveys, almost as if the universe was waiting for sharper eyes to finally reveal them. MOM-Z14 might hold the crown for now, but there's a growing sense it won't keep it for long. And that's where the real excitement begins. With every new observation, the boundaries of the possible shift. If galaxies like MOMZ 14 were common, forming stars at breakneck speed and already rich in complex elements, then something important is missing from our picture of the early universe. Does this challenge our understanding of cosmology? Without a doubt. The Standard Model says the first galaxies should be rare, slow-growing, and chemically primitive. MOMZ 14 is none of those things. It's energetic, bright, and surprisingly mature. That doesn't mean our theories are broken, but it does mean the universe still has some very big secrets left to reveal. MOMZ 14 feels less like a final answer and more like a breadcrumb, a small but powerful hint that the infant universe may have been far louder, busier, and more chaotic than we ever dared to imagine. And if that's true, then what we're seeing now is only the opening act. Very soon, the story is about to get bigger. The Nancy Grace Roman Space Telescope is preparing to join forces with Webb, and together they'll do something extraordinary. While Webb peers deep and narrow, Roman will sweep vast stretches of the sky with remarkable clarity. Side by side, these observatories could uncover hundreds, maybe even thousands, of galaxies like MOMZ 14, each one a glowing signal sent from an era we barely understand. For now, though, MOMZ 14 stands almost alone, a fragile whisper of light from a time when the universe was still figuring out how to exist. Yet the deeper scientists dig into Webb's discoveries, the clearer it becomes that the cosmos is far less obedient than our rules demand. In fact, some researchers studying the data have begun entertaining an idea so radical it sounds like science fiction. What if our entire universe exists inside a black hole? Adding fuel to that fire, another strange pattern has emerged. When astronomers examine how galaxies spin, they've noticed something unexpected. By tracing the curve of spiral arms, scientists can determine the direction each galaxy rotates. In a universe with no preferred direction, those spins should be roughly balanced, half one way, half the other. But that's not what the data shows. Instead, a surprising majority appear to rotate the same way. According to the researchers behind this study, this imbalance doesn't fit neatly into existing models. And unsettlingly, it could hint at something deeper, perhaps even lending support to the idea that our universe formed inside a black hole. To grasp why that matters, we need to revisit how black holes behave. When enough mass collapses under its own gravity, it forms an event horizon, a point of no return beyond which not even light can escape. Anything crossing that boundary vanishes from the outside universe forever. What happens beyond that threshold is completely unknown, and it's within that mystery that black hole cosmology takes shape. Sometimes called Schwarzschild cosmology, this idea suggests that everything we can observe, the entire visible universe, may actually exist inside a black hole that formed within a much larger parent cosmos. Now think about the Big Bang. The standard picture says the universe began as a singularity, an infinitely dense point. Strikingly, that description sounds eerily similar to the core of a black hole. If our universe truly lies inside one, then the Big Bang wouldn't have been an explosion into empty space at all. Instead, it would mark the moment matter in a parent universe collapsed into a black hole, triggering the birth of a new universe on the inside. And that leads to a staggering implication. Every black hole in our universe could be the seed of its own newborn cosmos. This framework might even help explain why the laws of physics seem so perfectly tuned for life. Universes that emerge from stable, long-lived black holes may be the ones that survive, introducing a kind of cosmic natural selection. According to researchers exploring these ideas, this perspective could resolve several long-standing mysteries. Take entropy, for example. Black holes contain enormous amounts of it, vast stores of encoded information, which mirrors the information-rich structure of our own universe. Another intriguing piece involves something called torsion. In extended theories of gravity, such as Einstein-Cartan theory, torsion describes a twisting of space-time linked to the intrinsic spin of particles. Some models suggest this twisting creates a powerful repulsive effect at extreme densities, preventing matter from collapsing into an infinitely small point. If that's true, black holes wouldn't form true singularities at all. Instead, their cores could reach a critical density, rebound, and expand in a dramatic big bounce. That rebound might ignite a new universe inside the black hole. In this view, the Big Bang wouldn't represent creation from nothing, but the aftermath of collapse and rebirth, a cycle repeating across a vast cosmic hierarchy. Universes budding off from one another in an endless chain. There's more. Observations of large-scale cosmic structures hint that our universe might subtly favor certain directions. These alignments, known as cosmic anisotropy, challenge the assumption that the universe looks the same in every direction on the largest scales. If a preferred axis truly exists, it could point to undiscovered physics, or tie back to how our universe formed inside a black hole, or how fundamental forces behave at unimaginable extremes. At the same time, the presence of massive, mature galaxies so soon after the Big Bang continues to strain our understanding of how quickly cosmic structures should grow. Of course, the black hole universe idea isn't the only explanation on the table. Some anomalies could stem from earlier measurement uncertainties, even something as basic as how fast our own galaxy rotates. Whatever the final answer turns out to be, one thing is clear. The universe is getting stranger, not simpler. And these puzzling patterns are almost guaranteed to push scientists back to the drawing board. So what do you think? Let us know your thoughts in the comments. And if you haven't already, make sure to subscribe, because this mystery belongs to all of us. After all, this is your universe too.